Thanks, Ryan. So, hi, I'm Kevin. We're going to go over the lab that you see on my screen, Bracketology with Google Machine Learning. Like Ryan said, go at your own pace, or you can keep up with me. I'll be taking it pretty slow, so we're all on the same page. If you have any questions at all or confused on anything that we're doing, please ask and we can go over it. So, when we see a large wall of text like this, the protocol is just going to be read it by yourself. I'm not going to read to you. I trust that you can read it. And if I scroll past it too fast or you're not where I am, then again, just ask a question and I can go back and we can go over it. So, big wall of text, ensue protocol, read. Okay, so that was just a very obvious introduction to what we're doing. We're just learning a couple of technologies that use machine learning, and the goal of this lab is to predict winners, losers of March Madness tournament, which obviously is going on right now, and that's why we think this lab is going to be fun, because it'll be able to be useful for even if you want to use it for next year. So hopefully we all are on Quick Labs, are on the lab. We're going to hit the start lab button soon. When that happens, we've got this timer. It's not gonna be able to stop. So we're just gonna have to go through, hopefully, and get through part one. That is the goal, to get through part one today. You should have enough credits to get through part two on your own time after we're done here with this lab. So let's begin. Great. Okay. So once you've clicked the lab button, this should pop up, which gives you unique login information for the Google Cloud. So when you click Open Google Console, it'll bring you to a new tab. You can see my new tab, or am I only sharing the lab tab?
We can see it.
Okay, cool. So you're just going to copy in your username, password, and we're in. Okay. So once we've signed in, then we'll move on. We're going to open BigQuery. So in the Google console, once we open the navigation menu, we have to go down quite a bit. It is near the bottom here. So I'm going to open BigQuery. It brings up this page. And we should see something like this. Okay. All right, everybody should be here. Good. So if we go in here, and then we can drop down this menu. Now we'll move on. So big wall of text, go ahead and take a second to read. Okay, so that was just an introduction to what the NCAA March Madness tournament is. Basically just a tournament that goes on in March for college basketball. So now we have to actually find the data set that holds a bunch of information about previous tournaments in order for us to build a model and make our predictions for another tournament. So when we're in the BigQuery console, find the resources tab and then click add data. The resources tab is actually labeled Explorer right here, I think. So when you click on add data, it should bring up Explore public data sets. Good. And we're searching for NCAA basketball. Then we view the data set, and that should bring us back to the BigQuery console. And it does. Okay. So once we're in here, we can now come back here. And I think we should have it in here now. Right, I'm not seeing the data set. Did I do one part wrong?
I'm looking. It looks like multiple people are having problem loading their data set. I looked away for 1 minute, but you got to the big blue button that said view data set, correct? Or did you not get there yet?
Mm-hmm.
All right. Yeah, you can try Tio's suggestion. Let's see.
Yeah, I'm still not finding it.
This is interesting. We'll figure it out. All right, Kevin. When you hit the view data set,
Mhm.
it opened up a new tab, correct?
Yep.
Are you on that new tab right now? Hit that. Just stay there. To view this page, select the project.
Oh, I think that's what Simon said in the chat. We're logged into our other account now instead
Yeah,
of the.
when you switch the tab, it like puts you in your personal account again. So
Ooh, look at that.
yeah.
Oh, nice find. Nice find. Yeah, we gotta be logged into the same account that we were just logged into. Thank you for that.
Very good.
There it is.
Smooth as butter. Okay. So we have our data set. Well, actually, we have to go into this big range of data sets and then go all the way down to the ends. Find NCAA basketball, and then boom, we have all of the data sets available for NCAA basketball. So if we go into men's basketball historical tournament games, then click preview, that will bring up a data set. And this is just a big old table. Don't worry about the contents of it right now. That's what we're going to start working with later, but it's just a whole bunch of rows and pages of information about the past tournament games. So if we want to look at the details page, that'll just tell us specific things about the data set. We don't have to worry about that too much because it's just metadata about the data set. So we're going to start writing some queries about the data set so we can start getting some information. So in the query editor, we're just going to copy and paste this part in. Whenever we see a block of code, we'll copy and paste it in, let it do the work. And then we'll come back to this page to talk about what the query is actually doing. So go to our editor, copy, paste in, run. Gives us a bunch of results. We'll take a look at that after we talk about what the code is doing. So if you're not too familiar with SQL or any database languages, that's okay. We'll take it really slowly. So the select keyword basically means we're selecting different items from the database. In this case, season, games per tournament, and we're getting it from the data set that we chose. We're going to group all of the information we gather from the data set into this label season, and then we'll order it low to high in ascending order. So once we've clicked run, we get all of these results, which we do. And then it says we can scroll through the output and then take a look at all of the stuff that it came out as, just to relate what we got from what we were supposed to get, which of course it just tells us how many games were in each tournament throughout every year, which it does. Cool. And when we reach a check my progress button, in our experience so far, these haven't worked. Maybe it'll work today. Look at that. Cool. So this is just checking that you've actually ran the code from the code blocks before this checklist, this checkpoint. And if you haven't, and it says that you're not to this point, no big deal. As long as you've ran it and you've gotten the output, then you're good to go. So there's going to be some pop quizzes to this. Surprise. No big deal if you are unsure of the answers. That's why we're here. We can take these parts really slowly, talk about why each answer is right or wrong, and really they're very low stakes, just to make sure that you are understanding what's happening for us to go along. So how many NCAA men's basketball tournaments are available for us to explore? Well, for us to figure out that information, we just have to figure out how many seasons we were able to grab from the data set. So it looks like we have 33 seasons grabbed from the data set, and it looks like that's an answer. So I think it's 33. It's 33, because that's just how many seasons were in the data set. How far back in time does the data set go for the tournament? Again, we already have the results for all of the seasons in the database, in the data set. And as far back as it goes, 1985. There you go. Very intuitive so far. Again, if you have any questions, please stop me or ask me in the chat. Okay, so we're going to start getting into how we can start using machine learning that's relevant to this data set. So take a second to read this next chunk of text so we can get caught. Okay, so this big wall of text is basically saying that in a data set we have features, things like the team name and the team CL, things that it lists there. And then we're trying to predict a label, a win or loss, as the example that we're talking about here. So from our historical training data set, we know the correct answer for our label, who won or who lost. So if we were to preview the data set, it would show us for each game who won and who lost. So I believe that is true. And for future predictions, we know the correct answer. Well, we don't even have to have the data set to know that this must be false because it's the future. And if you can tell the future, then that's something else to talk about besides machine learning. You have a different talent. So false. Okay, so take a quick second and read this. So we'll go ahead and follow its instructions. In the left-hand menu, we can open up the data set, and then we can preview it, which I believe I already have it pulled up. I do. And this should be the same. Oh, there's two of the same data set. Is that what I'm looking at? Okay. Turns out this is the one I was supposed to be looking at. That's okay. It's got very similar information. The team, the game, who won, points, things like that. And then what season it happened. So we've got our data set. Our labeled column for the outcome of the game already exists as a column in our data set. Do we have a win or a loss column? That's all this is asking. And if we go down the data set, we have a lot of stuff that pertains to the winner and the loser, of course, because we have to know who won and who lost. However, we don't have a column which says win true or win false for either team. So this is false. For each specific basketball game, the data set has one row for the winner and one row for the loser. So now we actually have to take a look deeper into the data set to see what we're looking at instead of just a big wall of confusion. So in each row, we have information about the game itself, when it happened, in what point of the tournament it happened, and the date. We also have a team, its seed, did it win, and the name of the team, how many points. And then on the second half of the data set, we have the very same information, but instead of the winner, it's the loser. So the Indiana Hoosiers lost. They received 5, the school name, all the same information, just who lost. So from what it looks like, we have one game per line. So we have the winners and the losers on one line of each game. So this would be false because we only have one row for winner or loser instead of 2. Okay, so this win and lose market is similar to what we want to be looking at, is who's the winner and who's the loser. So again, we've got a big wall of code, so we're just going to copy that and paste it into our editor. give it a run. It's going to spit out results, and then we can go ahead and talk about what it actually was doing. So again, we're going to use the select keyword. We're going to select all of these features from the data set: season, round, how old is the game, which is just called days from epoch in the data set, and when it happened, and the day that it happened. We're going to create a label called win, and then we're going to take all of these features of the data set and label them as the things on the right side. So win seed is just going to be seed in the query results. And we're taking all of this information from our data set. Then we're going to combine that all together, all that information from above. That's what unit all is doing. We're just taking all of the information that we found from the data set and smashing it into one result. Okay, now we want to create a new row for the loser, in which case we're just going to do all of the same stuff and then create a new row for it. So if we look at our results, that is what we see happened, except for the sorting is not necessarily defined. No, it's not defined in any sort. So while there are new rows for each winner and loser now, they're not next to each other, which is okay if we just have new rows for all of our winners and our losers. And our output should look like this, which I believe it does. It does. Okay. Check my progress. Am I there? I'm there. Good. Let's keep going. So now we know what features we have, and now we can answer these questions. Why should we not use the points scored as a feature in our training data set? We do have that data available. That was one of the columns inside of our data set. How many points did each team score? So this is kind of an interesting question. Actually, I like this question. So take just a second to come up with your answer. I won't give this one away immediately. So take just a second to come up with your thoughts on this one. Okay. So we can go through each one and then figure out what is right and what is wrong. So this feature is only populated for recent games and should not be used. And again, this feature is referring to win points or lose points. So let's take a look. In our data set, if we go back to our data set, we can see is only populated for recent games, so it should not be used. Well, we already know that this is not likely to be the correct answer because this goes all the way back to 1994. In fact, from one of the first questions we know goes all the way back to 85, and I would not say that's recent. So we can go ahead and say that's not true. This feature is numerical and cannot be used in a classification model. Well, it is numerical, so I guess that part's true. However, usually numerical data is very valuable because we can easily compare them and they're very straightforward in what they mean. So I would say no, this one also is not what we're looking for, as I accidentally click on it. So this feature is only available at the end of the game, and for future games we're trying to predict the winner before the game ends, because if we predict the winner after the game ends, that is not necessarily useful, right? So I would say this is the correct answer. Okay, we've entered part one of the lab. We've gotten all set up. We've used the query a little bit, so now we're ready to get rolling. Take a quick second to read the text above the question and the question itself, and then come up with an answer. All right, so according to our last discussion, points are not necessarily a great determiner of who is supposed to win or lose a game. It's not great for predicting. So we can immediately just say, nope, this one can't be it because this one's talking about who scored the most points. So we can go ahead and say we're supposed to build a classification model to predict the next games. And speaking of classification model, this big wall of text will talk about a classification model and what we're going to be doing with it. Okay, so I'm going to reinforce the last bit of the paragraph here. There's going to be a lot of buzzwords, a lot of cool keywords being thrown around about machine learning. I highly recommend you take a look at them. All of them will be paired with a link to them. Logistic regression, for example, it'll take you to a wiki page, I think, with this huge explanation of what it is, some sweet math, and then how it can be used in machine learning. So we won't worry about the details during this lab, but please do check it out if you'd like on your own time. It's a pretty neat read. So let's get into creating a machine learning model with BigQuery, of course. So we're just going to create our own model. We have to get it into a project first. So I believe at this point, we're going to have to modify the instructions a little bit because the console has changed. So when we're looking for the create data set, it's going to be somewhere a little bit different, maybe. Okay. So we go here. Create data set. Okay. We're just going to call it Bracketology. Did I spell that right? No. Yes. And go ahead and create it. Now, we're just going to run another big block of code, which we'll talk about after we get the results. So I'll head back to my editor, copy and paste it all in, go ahead and run. We're going to get our output, which I think we can view if we hit go to model. Is that right? No. I see. So this is the part where I can't be so hasteful. It's going to take just a second to bring up the results because it's doing a lot of work over our data set. Training a model could take a couple minutes. In our experience, it should only take a minute and a half to two. If you have any trouble, if it takes more than 2-ish minutes, then please let us know. We can slow it down just a little bit. So while it's doing that, we'll go over what the code is doing. So we're going to create or replace a model. In this case, replace, since we had just created the data set, or created the model in the console. And then we're going to create a row for the winning team. So we have to select a couple of the features from our data set. We've already gone over how that works with creating a label and then calling it something from the big data set. And the season is going to be less than or equal to 2017. Combine all of that together into a result. All of that is the same stuff from before. Very similarly, selecting the features of season, and then we're going to create a bunch of labels. Did you lose? And then we're going to use the seed and the name of the school. And then we're also going to use seed and the school for the winners as well. And then taking all of this from the data set. So we have to then grab all the information from the same time frame, of course, before or equal to 2017. Let's take a look if ours is done. Not quite yet. Not sure how much time has gone by, but it's okay if we have to take a second to take a breather. Hopefully everybody can be caught up by now, because this could take a couple minutes, could take a little longer than that, could take less than that. We just have to go ahead and wait for all of the information from the data set to be put together into one result. Building models with robust data sets Should take a long time because that means your data set is pretty good. It's got a lot of information to go over. Does anybody have any questions while we wait? I think we're making pretty good time. Don't think I can go to my model quite yet. Not yet. And if yours is already done, then go ahead and continue on. Feel free. And if you get stuck, then we can catch up to you. Aha. Cool. Okay. So looks like mine's finished. Let's begin. Looks like I'm there. So go ahead and read these 2 short paragraphs before we start talking about the data set. This paragraph is just letting us know that we can take a look at our data set. There's a bunch of different information here. The ones that we'll be looking at mostly, these ones, what was being trained, and all of these parameters, how they change throughout the life of the model training. So again, to sum up what this paragraph is saying, what we want to avoid whenever we're training a model is overfitting. And overfitting just means that our model is almost trying to copy the results of our training set. It's just memorizing what's happening and then trying to regurgitate what happened in the training set, instead of us having a generalized model that we can apply a different data set to and giving accurate results for that. So that's what we want to avoid. That's what this paragraph is talking about. And then we can go ahead and take a look at all of the stats that happened about the model inside of the console. It'll come up to look like this. So we can actually take a look to see what the model did. We're going to go ahead and copy this into the editor. Give it a run. Our results pop out. And now we can take a look. It should look like this. It might be a little bit different. So let's take a look at what the code did and then what came out. So we're just selecting from our model the category and its weight. If you were unsure of what weight meant based on the explanation before, the weight is just how important a certain category is to the model. And then this is just, we're going to take all of those and put them into our output. That's all this part is doing. And then we're just going to order it by weight in descending order. So top down. Let's take a look at our results. These are seeds, and this is the weight. So basically, to the model, having a 1 seed is a higher weight than a 2, than it is to a 3, than it is to a 4, and of course it goes down by there. And intuitively that makes sense. The model predicted correctly there, because if you have a better seed, you're probably going to do better throughout the tournament, and if you have a low seed, then you're probably going to do worse throughout the tournament. So that's what this result is letting us know. The model uses the seed to weight the winners against the losers. And that is what this paragraph is talking about. If you have a low seed versus a high seed, you're going to do better or worse. So now we have predictions from a model. Now we have to see if that model did a good job based on the categories we gave it and the weights that it chose for each of the categories. So then we have a bunch of results here, and then very quickly let's go over the query again. So we're selecting from the entire output. We're just going to evaluate based on the training data set and the model. How did we do? You're going to have an output like this that has just a bunch of random looking numbers. However, this big note here explains what each of those numbers mean. So let's, usually we'll skip over notes, but this time we have to take a look at this note because it's explaining what our output means. So take a look at the note. Okay, so if anybody has any questions about each of those metrics, do ask. It's pretty interesting. Each of those can be affected by different results. If we care about certain positivity or negativity rates, then we can choose each of these metrics to be affected in some other way. Precision and accuracy, usually the most intuitive. How many did you get right out of how many were there to get right? So our accuracy was 69%, meaning we got 69% of the games correctly predicted. In my case, it's also 69%. Your numbers might be a little different compared to the example output and mine. So what can we do to improve the model accuracy? Because 69% is good, but of course it can be better. So take a quick second to come up with the answers to this one, because it's also a very interesting question. So take a second. So talking about points again. I think we've kind of gotten the gist that points are only used to measure winner or loser. It's difficult to use points to predict winner or loser, because each outcome of the game in terms of points is just, is this one higher than the other? Yes, winner. No, loser. And that's really all that's good for, is determining a winner, not predicting a winner. Now, if we add more features to our data set and retraining the model, that is obviously a positive one, because if we have a more robust data set, we can collect more information, then we can hopefully build a more accurate model. So I think this one looks good. Our data is only looking at the tournament itself instead of the entire basketball season. That does make sense. It would give us more insight about the teams. However, usually teams aren't playing the same teams that they play in the tournament. There's different conditions. It's called March Madness for a reason. There's crazy stuff going on all the time. So it's not likely helpful if we get data from the regular season if it's not necessarily relevant to the tournament. So I don't think that's a great option. I could be wrong about that one though. Ooh. So that is right. Let's talk about why it's right. We're just getting numerical values from the team. That's really all this question is asking for. How can we get more numerical values from the team? We're building a classification model, right? So as long as we have lots of numerical values, then we can potentially build more and more accurate models. So let's make more predictions, yeah? Take a quick second to read what this code is about, and then we'll go over and put it into our editor and then run it. So now that we know what we want to do with this code, let's throw it into the editor, give it a run, and then talk about what the contents of it are doing. So we're going to create or replace a table. We want to make predictions for the 2018 season. Yes, this is a little bit dated, but that's okay. We're just going to pretend the 2018 season didn't happen already, so we don't know the results. So we're just going to, using the model that we made, we're going to predict the next season. And we've run it. If we go to the table, hit preview, we then get a bunch of information that our model has predicted. It's just a big table of winners and losers about the 2018 season, predictions that we had made, that the model had made. Okay, so let's talk about points again. Why do we bring back the data columns for win points, lose points, game date, and round and hour prediction? Isn't that not allowed? Take a second, come up with your answer. Okay, so if you're to take a look at your output, you'll see that, oh, you don't see my output. Okay, if you take a look at the output, you'll see that the points column is back. And we've talked about why points aren't good for this. So why are we looking at points? Well, since the model is already trained on not points, adding these columns back only adds context. That sounds good to me. So sure, it's always good to see more information, especially if the model wasn't trained on it or didn't need to be trained on it. And you should not include these columns in your prediction output. Well, it's okay because it's just a prediction output. It's not using the model to, it's not using the points to predict the output. And there we go. So very quick read again. Okay. So we have these predictions, but they're only good if we know if the accuracy was high or if the precision was high or any of those other parameters. So let's put this code into our editor. You're going to have a lot of tabs, so if you need to get back to your editor, just click on the left arrow here or just close the other tabs that we don't need anymore. So let's take a look at the query to see what it's doing. So of all of the results from our predictions table, we're just going to find the labels that are less than and greater than. which means we should have 38 outcomes. And since we're finding the ones that are less than or greater than, not equal to, that means we got 38 wrong because those outputs are the ones that are not equal to our correct label. And that is 70% overall for the 2018 tournament, which is about what we expected considering our accuracy and precision was around 70% last time. So another quick read before we enter some more queries. Okay, so let's use this one. We're just going to copy and paste it and then talk about what it is doing. So in a high level, the paragraph before is just saying, we're just going to take a look at what were the biggest upsets. At what point did our model think this game is definitely going to come out this way? I'm very confident about it, but for some reason our model got it wrong. Sorry, I can unmute myself for a second. Yes, we're just looking for the biggest upset. When was our model very confident, but we got it wrong? So from the predicted label from our model and its confidence and all of these features, when was our probability, our confidence level above 80%, but we did not hit the correct prediction? Our outcome is going to look like this, just a couple. And then we can take a look at this outcome and see what were the biggest upsets. In this case, the biggest upset was the highest confidence but got it wrong. So it would be row 2, where seed 16 UMBC beat seed 1 Virginia. I remember that. I was watching it. It was nuts. Obviously, Virginia was supposed to win, but got beat up by UMBC. There's actually a video linked to the highlights in the lab, which I think is hilarious. Google just wanted everyone to know that Virginia got beat up by seed 16. So yeah, that's what the output of this is talking about. We have very high confidence that Arizona is supposed to win, but Buffalo won. Again, that's just March Madness. Our model was just taking in all this information and thought, well, this team's supposed to win, but our model predicted wrong because our model can only take us so far. So let's take a recap. We've built our model. We've figured out how far it can go. And then we predicted some outcomes. We even analyzed a little bit of what the predictions were like. So that's the end of part 1. Does anybody have any quick questions? If not, we can have another quick look at any of our output. We still have plenty of time in the lab. We're not going to move on to part 2 because our plan is just part 1. I think taking a look at your predictions is pretty neat because we've built this model that is now predicting the outcomes of games simply just based on all of the features from our data set, seed, even name of the school, and in what round and things like that. So that is part 1 of Bracketology with Google Machine Learning. Please do part 2 on your own, or you can just continue on right now if you'd like. Ryan, do you have anything?
Yeah, so first, that was a really good run through of part 1. So thanks for that. That was good. And what we're going to do is we're going to stop the recording and stop our little study jam right now. If you want to stick around and either work on part 2 or you want to talk to us about anything machine learning or basketball or whatever, stick around. We'll be here for a bit. And other than that, thanks for coming.